All right, so up to this point, we've talked about dot plots and histograms informally. I haven't even really introduced histograms formally, but we looked at it on our calculator. And then we even kind of looked at these box plots. I don't know if you remember that, but we're going to study those things formally. Really, we've only looked at dot plots. So now let's talk about some other numerical plots other than a dot plot. Stem plots, or stem and leaf plots. You've probably seen these before, or if you haven't, you could probably look at these and kind of figure out how they work and what they're telling you. The data below shows the number of wins for each of the 30 Major League Baseball teams in 2012. Make a stem and leaf plot of the data. So I'm not actually going to make it. Very rarely do we make these. Now, on the AP test, you are expected to be able to create stem and leaf plots. In fact, these are one of the plots that your calculators can't make. So it's kind of a common question for them to ask you to make because they know your calculators can't do it. But I made them for you using computers. So this is called the stem. So the stem represents the tens place of the number of wins. This is called the leaf. That represents the ones place of the wins. So this would be 81 wins, that's one team, 85 wins, 88 wins, 68 wins, 69 wins, and it kind of gives you this picture. Now when you do these, you want to use a font where every character takes up the same amount of space. You wouldn't want one that does 1, 1, 1, 1, and then like 8, 8, 8, you know. You want the heights of these things to kind of represent the frequency of that bin. After all, this bin is represented by all the numbers from 90 to 99 and 80 to 89. So what you can do is I'm flipping my computer on the side, but if you just tilt your head to the side and kind of look at it, I can't show you how I'm looking at it, but look at it sideways, this kind of looks like a histogram. So you can kind of get a picture of the shape. There's very few values up here, and then as you get higher, you got more values. Okay. This one is called a split stem. We just took these 90s and we broke them into 90 to 94 and 95 to 99. So what it does is it basically spreads out, or if this was a histogram, it changes the bin settings on your histogram. Now on a histogram, you can change your bin settings however you want. On a stem and leaf plot, you can only do certain kind of bin settings. Okay. And that gives you a picture of this. Now be careful about this. If I look at this distribution, it kind of looks like this, right? Looking at it sideways. So if you look at it this way, you might say this is majority of my data, small tail, big tail, so you might say this is skewed to the right because I'm looking at it, so that's my right. But be careful about that. It's skewed to smaller values, not larger values. So this would be skewed left, even though it looks like it's right. The reason it looks like that is because I started at 9s and I went to 6, 5 instead of starting at 5s and going down to higher down here. Okay, if I would have made it this way, then if I look at it from the left side sideways, it would look skewed left. So you got to be careful about that. Think about whether it's skewed to bigger values or smaller values when you're looking at stem plots. Okay, all right. Example. Pokemon. Below is a stem plot of the ages of young people at a Pokemon tournament. Describe the distribution. So we got split stems. Now these are actually split into twos. This is 10 and 11. This is 12 and 13, 14 and 15, 16 and 17. So each of these has got two numbers in it, I guess. So we're going to describe the distribution. We're going to cuss with context. So centers. Now we're going to learn specific measures of center later. For now, we're just going to talk about middle. So I guess you might say this is the mode, right? But there's a lot of values here, so that kind of pulls the center down up a little bit. So I'm going to kind of say the center is right about there. I'm going to say 14 or 15. I'm going to say 15. The ages of Pokemon players at this tournament is centered about 15 years old. This is a very informal kind of thing. Don't say the average, don't say the median. We're going to learn those things later, and eventually we will, but for right now we're just going to kind of say in general. Instead of saying the data is centered about 15, that would not have context and you would lose points on the AP test. So I don't like to go in order. I like to do spread next. How spread out it is it? Well, it spans from 9 years old to 25 years old. Ages span from 9 to 25 years old. Again, in a little bit, next lecture, whatever, we're going to talk about specific measures of spread also. Shape. So I'll turn this thing sideways. And I kind of see like this. The question is this a significant omission of data to give me bimodal data? I think if I drape a moderately heavy blanket over that, I think that's going to be unimodal. Unimodal. And then this would be skewed to the, it looks like it's to the right, and the right is positive value, so that is skewed right. Again, I'm circling my middle data, small tail, bigger tail. And unusual features, none. You don't have to put that, you could just omit it altogether. But I don't really see any outliers, I don't really see any gaps, I don't see anything weird, so I'll just say no unusual features. Okay? All right, very common test question, A/B test question that is really pretty easy. We also cuss when we compare two distributions. The key differences though, well, we use context on the other one as well, but when we're asked to compare two distributions, we must use comparison words. We can't just say one is centered at 15 and one is centered at 20. That's not comparing. That's describing this center and describing this center independently. If you want to compare, you'd say the center of this is less than the center of this, or the center of this one is greater than the center of that one. So comparison words, less than, greater than, equal to, make sure you use comparison words. AP is very picky about it. Example, top versus bottom freezers. So some freezers have their freezers on the top, some have them on the bottom, some of them have them on the side. We're not considering the side ones. So the question might have been for consumers, are refrigerators that have their freezer on the top, are they more efficient, energy efficient, than the ones that are on the bottom? So here's the energy costs, annual energy costs in dollars for these two types of fridges. And it looks like the top fridges require less energy, right, than the bottom ones. Some of the bottom ones are really cost a ton of money to keep running for the year, right? A lot more money relative to the other ones. So let's compare. I think you would find if I asked you to compare this, you just did it informally, you'd talk about where this is located, that this is spread out. You would do these things that we do when we cuss anyway. The cuss is just kind of a way to help us formalize it so we can make sure we get everything and make it a little easier. Centers. The center of energy costs for bottom freezers, yeah. That's going to be centered like right around here somewhere, right? Is definitely greater than costs for for top. And it's okay, you don't have to write, you can kind of, I should say, is greater than the energy cost, than the center of energy costs for top, and maybe I should say center, then center costs for top. You can shorten things up a little bit, but just make sure you get some of those keywords in there. Center, for example, is a keyword. I got context. Spread. This one is way more spread out than this one. That's probably, in my opinion, centers and spreads are the two biggest differences. So the spread of energy costs for bottom is much greater than for top. Okay, so again, I kind of shortened this up here a little bit, right? I didn't say then the spread of energy costs for top, but I think that's okay. In fact, if you, on the AP test, if you are good about context in the first part, you could probably just say bottom is more spread out than top and not really talk about energy costs at all because you have context up here. As long as you have context somewhere, usually you're okay. You gotta be careful with it. You don't want to cut corners and lose points, but shape. So top, and this is one you don't really have to use comparison words. I'm just going to describe these two separately. You could, but I'm not going to. This looks like it's unimodal symmetric. So top is unimodal symmetric. And then the bottom looks like unimodal to me. I don't think this is a significant peak and this is another, so I'm going to say unimodal. Unimodal here, and then circle your data, skewed to the right. So if we wanted to use comparison words here, we could as well. They don't care about it as much on this one, but we could say they are both unimodal. However, top is symmetric and bottom is skewed right. But comparison words here are not needed. Just by how they've graded past tests, comparison words are here and here is where it's needed. Unusual features. It looks like there's no unusual features for top, but it looks like here we got a couple outliers on the large end. So top has no outliers, but with one T, but bottom fridges have two outliers with unusually high energy costs relative to other bottom freezers. Okay? And again, down here, this got a comparative nature to it. Top has none, bottom has some, but the comparison words are really, really important with these two. Is greater than and is greater than, okay? Very common mistake on the test, guys. Please don't make it. Comparison words for centers and spreads, please, okay? All right, so now we're going to start talking about some, next video we'll keep going in the notes.